Here we go. Precalculus, trigonometry, parametric equations. Write down the definition of parametric equation. This is a very hodgepodge definition, but it's the best one that I think that we'll readily understand. Parametric equations are equations written dependent upon an additional parameter. An additional parameter. A parameter is kind of like a variable. It's something that helps distinguish the values. Most commonly, the additional parameter is referred to as time. Yep. Most time. So here's what happens. I'm going to high jump, okay? You guys ready? It's going to be impressive. There we go. What do you think? How about a round of applause? Is something? Okay, great. All right. Here's the deal. Did my horizontal displacement change? Yeah, X changed. Where I was horizontally, that changed. Did my vertical displacement change? Okay. My Y value went up, it came back down, so Y changed. Did time go by as I was doing the activity? Yes. So, as time went by, my height changed. As time went by, my horizontal placement changed. Okay? So instead of writing X and Y dependent on each other, X and Y can be dependent on time going by. That's what happens. And we can graph equations this way as well. Let's start at time equals 0. And we'll then go to time 1, 2, 3, 4, 5, 6. First question in your assignment today will be just like this. And one of the problems on your test is going to be just like this. You're going to have to generate a graph using parametric equations. And all we do is we use these t values to find the x values. For example, what is 0 squared minus 3 times 0? What is 1 minus 3? What is 4 minus 6? How about 9 minus 9? How about 16 minus 12? How about 25 minus 15? And 6 squared minus 3 times 6, 36 minus 18. So we know our x values that we will plot. We do not yet see the y values that we will plot. We find those out by taking whatever t is and subtracting 1. So I have 0 minus 1, 1 minus 1, 2 minus 1, 3 minus 1, 3, 4, 5, so on and so forth. We continue to use an x-axis and a y-axis. As we use our x and y-axis, we plot these points. I'm going to go all the way over to 20. And I begin to plot. My first point is 0, negative 1. 0, negative 1. My second point is negative 2, 0. Back to up 0. My third value, back 2, up 1. Zero, 2. 4, 3. $10, 4. And 18, 5. Tell me something interesting and intelligent about the shape. Scott? Okay, it's a parabola that's horizontal as opposed to vertical. Any other thoughts? That's what Apollo 13 did around the moon. All right. We're kind of missing part of it, aren't we? Why are we missing that part? That part is for where the time is less than 0. So that will be for negative time. What it would have been. Okay? You can't have negative time really in the real world, but well, no, we talk about history, right? I mean, we could look at that a little bit. Let's try to graph this on your calculator. Please take out your calculator, and we're going to all make sure we're kind of in the same world right now as we graph. Press mode, and as you can see, there's different modes in which you can graph. You've always been working with the function mode, otherwise known as the rectangular mode. Okay? Next one over is parametric. I will also teach you tomorrow polar, and we will not learn sequential. Parametric mode is what you want to enter. Mode, let's work in radians. And now let's go to our window. The window is very normal. It has the x min, x max, x scale, y min, y max, y scale, so on and so forth. However, these three right up here are different. T minimum, that means the first time. So since we start with time equals 0, we'll start with time equals 0. T max would be the last time that you would have, or in this case, say time 6. The T step is how often you take a step. So you could say every 1. Well, let's plot every 0.1, okay? It's just better. It'll create the whole graph. And then we could go to our x mins. My smallest x value looks like -10. My biggest x value looks like 20. My scale, I've got a tick mark every 5. My y min is -5, my y max is +5, and I've got a tick mark every 1. And if we press graph here, we should come up with that exact same shape that we just put. What happened? Oh, I know what happened. Window. The scale for y is we have a tick mark every 1. I never put in the function. Go to y equals. And you can see there that we put in the function. And we're supposed to put in t squared, so t squared minus 3t. And then if we go down, we get t minus 1. Now I graph. So the way you get t, or any variable, is to press that button right there. That is your variable button to enter when you enter functions and stuff. The window? So I'm just entering these. T squared minus 3t and t minus 1. And it should generate the same shape that we have. And if I press graph, you can see, is that the same shape? You can see it doesn't have the negative portion. If I go back to window and I create a negative time, say -3, you can see now that it will create the entire shape. See the difference? Question. This is not a function. It's not a function. Y is not a function of x. Okay? So as you've learned functions, only one input for every output, okay? Or every input corresponds to exactly one output. But look at this. X equals t squared minus 3t. That is a function, okay? X is a function of t. And y is a function of t. So that's a way to get around kind of the function need for your calculator. These are very popular. Also, like I said, you can decide how to begin and how to end. You want to begin and end in the appropriate spot. You just change it. We got 0, and now it just starts there. And that way you've got just the segment that you want. Now, let's do some algebra. It says write an equation by eliminating the parameter. So we have x equals t squared minus 3t, and we have y is equal to t minus 1. If we want to eliminate the parameter, what is the extra variable that we want to go away? We want t to go away. If we want t to go away, we need to solve for t. So y plus 1 is equal to t. So I'm going to take this t equals y plus 1, and I will place it right there. Now I will no longer have a t value, or a t variable. I will only have x and y. Let's simplify this. X equals, what is y plus 1 quantity squared? Right? So, combine like terms, x is y squared minus y minus 2. It can be equal to y. In this case, it's equal to x because it's a horizontal parabola. If yours is equal to y, it's incorrect. How's that? Are we okay? On your assignment and on the test, that's what you're going to have to do. Can you do that? Generate the values, graph it, do that. Okay. Next example. Describe and graph the curve represented by the parametric equations. I'm going to change this to 2 pi. Sorry about that. Can you just look at this and determine what that graph is going to look like? So let's plug into our calculator and see what it's going to look like. We go into y equals, and we type 3 cosine of t, and then 3 sine of t. What is the t minimum value for this problem? 0. What's the t max value for this problem? 2 pi. Okay, let's look in a normal viewing window. We'll go negative 10, positive 10, 1, go negative 10, positive 10, 1, graph. What is the shape? It is a circle. It doesn't look like a circle because our picture is distorted. If we did zoom as a square, number 5, you can see that it will create a perfect circle for you. What's the radius of that circle? 3. Do you remember the equation for a circle as we learned it using x and y? the circle equation, right? Remember that? It's the same thing as the Pythagorean theorem. We've used that a billion times, haven't we? So, we should be able to... Does this have a t-value in it? It does not have a t-value in it. We should be able to get rid of the t-value and write this in terms of x and y. Let's see if we can do that. I have x squared plus y squared on one side. I'm going to put x squared plus y squared on the other side as well. What is x squared? Nine cosine squared. What is y squared? What do you see, Scott? I can factor out a 9, and I get cosine squared of t plus sine squared of t. What is sine squared plus cosine squared? So you end up with x squared plus y squared is equal to 9. What's the radius of a circle like that? 3. Is that what we had? Yes. So we generated an equation based off of this information. You're going to have to do that in your assignment today, one problem. Okay? Just a circle. Other people have asked, can we get other shapes? Yes. This shape right here is an ellipse. Cross it out. We don't have time. This shape is a parabola. We don't have time. Cross it out. But we do have time for number 5. Number 5 says we are now going to take, and instead of writing something in rectangular form as we've done, we're going to write it in parametric form. So we go to work. It is a line, and you will have to do this on your test and on your study guide and in your assignment. What? We just place things into rectangular form. We're now going to place them into parametric form. It says, find a parametric equation for the line with the given properties. It's supposed to have a slope of 4 and pass through negative 2, 5. So I plot back 2 and up 5. If this line has a slope of 4, can you tell me what would the next point be after that? You would go over 1 and up 4. As Scott said, it would be negative 1, positive 9. And if you want to find the point before that, you would go down 4 and back 1. So negative 3, positive 1. And you then get this line that we are going to try to write a parametric equation for. Now I want you guys to understand, there is an infinite number of equations that you can write that would work for this one. You just have to come up with one. So I will show you how we do it. Don't write this down, but please follow this logic, otherwise you're not going to get the next piece. If I have x, y coordinates, negative 1, 0, 1, 2, 3, and I go 3, 5, 7, 9, 11. There we go. Okay? If you wanted to write an equation for the line that passes through those points, let me ask you, what's the slope of this line? For each one you go over, how much do you go up? 2. Second of all, what's the y-intercept? 5. When you have an x value of 0, you have a y value of 5. Everybody see that? Okay. Now you'll be able to do this part. Instead of x and y, I create x, y, and t. There are other ways to do this, but every time I do it the other way, people don't understand it. This is the way that people seem to understand. At what time would you guys like to start? 0. We'll create some points. Now, which point would you like to start at? -3, 1, -2, 5, or -1, 9. You can choose. Okay, -3, 1 sounds good. So, when time is 0, we chose. This is how your answers will be different. If you so choose to start here, your answer will be different. If you so choose to start here, your answer will be different. I'm going to start here. X value of -3, Y value of 1. Watch the change. At my next step, I go over and up. What's my new location for X? -2, Y is 5. I go over 1, up 4. My new location for X is -1, Y is... How much are the X's going up by each time? So this one would be 0. How much are the Y's going up each time? That would be 13. So, just like we did before, instead of having a y out front, now we have an x, and we're going to have t as a variable. Let's figure out the slope of x. As t goes up 1, x goes up 1, right? We put a 1 in front of the t. What would be the intercept? When t has a value of 0, x has a value of -3. Convince yourself of it. If you plug in 0 for t, do you get -3 for x? If you plug in 1 for t, do you get -2 for x? If you try all those points, you're going to come up with what you need using that formula. Let's do the next one. Y equals something with regard to t. Okay, what's the slope of y? 4. What's going to be the starting point? 1. That's it. If you want to see if you get the right graph, go ahead and turn on your calculator and plug it in. I can graph t minus 3, and I can graph 4t plus 1. And when I graph them, is that the line that I have? It sure is. On your assignment for today, I'm not trying to create a lot of problems. I simply have these 6. 3 problems like we start at the beginning where you graph and remove the parameter. I have 1 problem like the circle one that we did. And then I have 2 problems where you write equations for lines in parametric form. What? Oh, yes. Because you're asked to. Yes, mostly with motion, where you have beginning points and ending points, and sometimes those motions would go something like this. Okay? Can you write an XY equation for that? You have no chance. But you can write parametric equations to do exactly that. No. Nobody would write parametric equations for a line, probably like we did, but that's the most simplistic way to start the question. Yes. Well, I'll just say the circle one is a classic one. That's one that gets used quite a lot. Quite a lot.